So, hello everyone. I would like to thank you for inviting me for this event. It was a very long way for me because last time I had a standing invitation for DENOG 8 years ago. So, I'm finally here and I'm happy about it. Thank you for coming. So, in this presentation, I will tell you about our experience with deployment of BGP Flow Spec for DDoS mitigation for multiple customers in many places, and I hope it will be useful for you. I would like to introduce myself. So, I'm Pavel. I'm author of FastNetMon. You may be familiar with it. And I'm CTO of FastNetMon Limited. So, I believe only way how we can actually reduce impact from DDoS attacks is by cooperation, sharing information, sharing tools, approaches, policies. And so, that's the reason why I started this presentation from sharing my contacts. I'm very open to talk about DDoS. I'm really passionate about it. So, let's talk. Let's begin from talking from DDoS weather. Why weather? Because it's very unpredictable. Because if somebody will tell you, like, look, I expect in next month we will have more DDoS. It may be right, it may be wrong. It's exactly as stock market or with weather. So it's very unpredictable. What we have definitely for sure have numbers about what happened previously. And we have data kind of provided by a Dutch non-for-profit DDoS scribing center called BIP Neves. And you can see, so DDoS attacks are still here. They didn't disappear, unfortunately. So they're still disastrous. So you can see peak capacity about 300 gigabits. So it's more than enough to knock down most of the network. So they're still dangerous. But good thing is, you can see on the right side that they are mostly still amplification, which can be handled in some ways. So we still have a problem to solve. But is it a problem or not? We have a great tool implemented by a well-known BGP unicast protocol, which is BGP Blackhole. So if we receive lots of traffic against specific customer or against specific service, we can mitigate it this way. We just need to create BGP Blackhole announce and problem sorted out. Again, I may expect some questions about it because from perspective of customer who was actually blackholed, it's hard to say that it was mitigated because and that's the reason why when we talk about mitigation, most of the time I will talk about perspective of provider, of carrier, because our point is to save network. If we have one service which is under attack, we can afford to sacrifice it and then handle it this way, what we can do on next step. So even better if you have some kind of automation for Blackhole, and may I ask if anybody from this room running FastNetMon for their network? Can you raise hands? Not so many. That's bad. So try it. So what is the problem? We have Blackhole, we have DDoS, we can mitigate it. Is it right or not? What is the problem? Why we need to talk about? Why we need some fancy protocols, which are actually quite complicated in their nature? So problem is one of examples of attack. Like you can see on this slide, it's a real example of attack which happened around 4 months ago against one of our customers. So you can see what happened. Attack wasn't targeted against specific /32. It was targeted literally against every single IP in range of /24. You can see, you may try to mitigate it by using BGP Blackhole, and you will end up running out of address space. So because you can sacrifice one customer, you can sacrifice 10 customers, you can sacrifice 100 customers. But in some cases, actually, what attacker is doing, they attack every single prefix you own. And by the end of the day, you will blackhole literally every single IP in your service. And then what you can do, that's the reason of current presentation. So, and BGP Flow Spec here to help us. What is BGP Flow Spec? Of course, it is BGP family of protocols. It's just BGP NLRI implemented off top of transport of BGP protocol. But how it works, how it can be explained in single sentence. And so far, my favorite explanation, what is that? What is a BGP Flow Spec? BGP Flow Spec is a protocol to manage distributed firewalls. That's all. So instead of making ACLs on one machine, you can make ACLs on one machine, and then it will magically distribute it over network. That's all we need to know for now. What we can do using BGP Flow Spec? BGP Flow Spec is mostly focused on terminology of protocols most of the routers deal with. So it's levels 3 and levels 4. So literally everything you can find out in levels 3 or levels 4 of OSI model, you can find as terms of options possible to filter out and match using BGP Flow Spec rules. So you can create rules which match source IP, destination IP, source port, destination port, some TCP flags. But if you want to look deeper, like HTTP protocol, DNS flags, it's not about BGP Flow Spec at all. Unfortunately, for this kind of attacks, you will need something different. In this case, we will talk about mostly volumetric attacks and attacks against actually network infrastructure. So if we have facility to match specific types of traffic, what we can do after we match it? Because if you talk about standard like firewalls, standard firewalls, they can actually filter traffic out or pass it, simple. But BGP Flow Spec is way more flexible because in addition to dropping traffic completely, which is maybe desirable in some cases, we can tag it special way for purposes of handling in different way on next levels, or we can redirect traffic to specific router, which is allocated only to deal with malicious traffic, or we can take some specific, move it to specific VRF function on router to handle it again in specific ways. So you can see it's one of the ways how you can actually not only block traffic, but also market for future processing. And let's talk a little bit about BGP Flow Spec standard, because it's standard, which is great. So not so many things, we have great standards now, and BGP Flow Spec is one of them. So work group started work in 2003, and by the 2009, they had finished draft and it was published. And how it actually correlates with vendors' implementation, because sometimes vendors wait for years or decades before actually implementing it, or sometimes they start it before somebody started working on like even draft for standard. What happened in case of Flow Spec? Because one of the main issues, I believe, with BGP Flow Spec that so many people think that BGP Flow Spec is new protocol. It's not. I'm sorry. So, but there is one problem, this thing called internet. It's quite complicated to find out something which is really old. And actually what I tried today, I use it on Juniper, because for me it was well known that Juniper was first implementation of Flow Spec, which was suitable for production use. And so I opened their feature explorer and find out that, okay, only version which actually supports BGP Flow Spec, it's Junos 12, which was released in 2012, 3 years after we actually got standard published. Is it right? No, of course not. Because it's only actually just oldest version available on their site. So it was impossible to find out previous one. Thanks to great approach for storing old information from DENOG, I was able to find out version of Junos 7.3, which moves us a little bit backward to 2005. Again, 2005, it was exactly 17 years ago. So by the next year, Flow Spec can go to store and buy alcohol and enjoy himself for like Friday evening. So but even more interesting, because for now I have proof of confirmation, like this one was added in Junos 7.3, but is it right or not? Exactly, it's not. It was added in Junos 7.2. But it's almost impossible to find it out because it wasn't mentioned in changelog of Junos itself. I have an explanation why it happened, but it wasn't. So it was here, and I was here. You were able to create terms of filtering, but it wasn't mentioned anywhere. It happens. And what about different vendors? What I can say? One of the first after Juniper, it was Alcatel-Lucent, also known as Nokia now, and their implementation arrived in 2011. Not very fresh, but from my own experience and experience of our customers, it just works most of the time. It's really great. Next one was Cisco. Their implementation also has no complaints because I suppose at point of time after 5 years after standard was published, most of the corner cases were resolved or sorted out in some ways, and it also works fine. But still you have quite limitations about how it actually implemented on hardware side, but I will talk a little bit later about it. And what happened next? happen at next issue with clicker? I'm sorry. Okay, and next one I would like to mention is GoBGP. If you're not familiar with this amazing tool, I would recommend to Google it. Because I believe it's only one developer-friendly way to work with BGP protocol. And it's really great. So it's not about using some dodgy command lines with encoded this like binary language. So you can just use like protobuf, gRPC, REST, and just enjoy your project you want to implement instead of trying to work with BGP protocol internals. So it's really amazing. That's the reason why I mentioned it. So for fast and fun community version, we recommend it using, and it works just great. So BERT, after next. Also amazing and not so that popular yet as BERT1, but still, and it supports BGP Flow Spec, and you can try it. And next one, it was 2008, and it was time when actually support from more vendors, like Extreme Networks arrived, and just after that, just 2 years later, Arista managed their support for Flow Spec. And again, 17 years later, we are here. And every single major telecom vendor actually finally supports it. I'm really happy to say it, because last time I made similar presentation, it was 6 years ago. And when I mentioned Flow Spec, lots of people like, is it experimental stuff? Is it like something which will work? It will happen? So it happened. It's here. It's supported by literally every single vendor. I'm not talking about old models, but if you buy equipment right now and use real modern software, you will have support for Flow Spec, which literally means main point of my presentation, like it's ready for like real cases, and you can deploy it with high percentage of guarantee without any possible issues. But what is the problem? Because I mentioned it, like I will tell about problems. There are lots of problems. I wouldn't call them problems, it's more like issues, because you know, when you deploy some technology for real cases, you will see that it will not work exactly as expected. So first one is vendor implementation problems or hardware limitation. But you know, it's not news. For every single network engineer, it's well known that if it doesn't work as expected, it's kind of expected. So if you want to deploy BGP Flow Spec, allocate lots of time to carefully test your specific version of software and hardware that it works exactly that way as you expect. Because it may not, in very obvious cases. So, and there are multiple issues about number of Flow Spec rules on specific platforms, and you need to be familiar with your platform and the limitation of your hardware. But more important, there are serious gaps in every single vendor about ways how you actually monitor Flow Spec. So if you, for example, decided to deploy BGP Flow Spec for your network, it's fine. Your next step, so you enable it for your network, fine. And then you want to filter out some traffic. For example, port 179, because why we need it? And after that, you need to understand, is it working or not? And that's how problem starts. So we have a tool which actually allows us to create rules. For example, block all UDP traffic on specific prefix. Fine. But we literally have no way how we actually monitor that it actually filtering out something. And that's a problem, because we have a way to deliver rules, but we have no vendor-neutral way how we actually monitor that this rule actually works. And for every single vendor, we need to use custom approach to retrieve counters. Like, for example, when we created BGP Flow Spec rule, we need to filter, count how many bytes actually we filtered. Or is it working at all? Is it not? And that's a large problem, because for all the vendors, we have no such ability, and you need to use vendor-specific implementation, custom vendor API, protocols such as netconf, or different command line tools to do it. It's doable, but still it's quite a large gap. You need to keep it in mind, because it may cause problems, like of course for monitoring and for customers. And what more interesting is that there are some problems between integration when you need to understand that actually some traffic was filtered out by Flow Spec rules, and you have integration of IPFix and NetFlow coming from all your routers for some kind of collector. You have a network, and then you can expect that when you filter out traffic using BGP Flow Spec protocol, it will be market some special way. Because, again, if we talk about protocols like IPFix, they're unlimitedly extendable. So you literally can invent your new fields. You can easily create even standardized fields. It's quite simple process in general. But unfortunately, it's implemented only by a small number of vendors. So, some issues. When I mentioned that if you want to deploy Flowspec, you need to be careful and very, very precise in testing. So that's exactly what happened with router. Small thing, Cisco ISR 9K, suitable for home use only. And when actually you read this kind of issue, when it actually officially cannot filter out traffic which was fragmented. One step back, why fragmented traffic is important? Because normally, who cares? That's a problem because most of the attack ways have most of the most disastrous and large-scale DDoS attacks are implemented. They implemented using an approach called amplification. And due to the nature of amplification, you will see large percentage, I would say at least maybe 30% or 40% or even more of traffic which is actually fragmented because when amplification happens, endpoints who actually generate traffic, they send some large packets, like 10,000 bytes, for example, and then routers to deliver them, they fragment it. So to filter out DDoS attacks efficiently, you need to have support for fragmentation. And you can see what exactly happened. So I believe it was some kind of hardware limitation on their side, but still it's one more reminder that you need to be sure that your platform at least was able to filter out at least most popular traffic vectors. So it's fragmentation, it's UDP protocol, it's some port matching, that's all. Arista is more interesting in some ways because they have a think about specific TCP flags. I don't know, because of course I understand that now they use flags like CWR or NS. But what happens, so for example, if somebody from attacker side decides to use them for attack? And then, when you generate rule in attempt to filter it out, your router will just discard it. That's all, nothing will happen. And one more interesting thing to mention about Arista in general and extreme networks. They have quite limited support of terms of Flowspec. So they explicitly state that for some hardware versions and previous software versions, you cannot use, for example, a term called isFragment. And what happens if you actually use it? Instead of just ignoring silently, it will discard Flowspec rule completely. And for some implementation which are not aware about this behavior, they will try to assume okay, what happened, and it was completely discarded. And that's the reason why you need to understand limitation of your platform, because if you want to use some software which actually generates Flowspec rules, you need to adjust it to avoid using some terms which are not actually supported by your hardware. Because unfortunately, in protocol, in standard of BGP Flow Spec, there are no ways to expose what kind of terms are supported by router, which terms are completely unsupported. So there are no way. You just try to send something, it discarded, but you have no explanation why it was discarded. So that's one more reminder that you need to be very careful with how it's implemented. One more thing to talk about tracking of discarded traffic. So again, you decided to drop some traffic on your edge. Let's imagine you have hundreds of routers. And you just want counters. You just want to understand how much exactly every single router discards for this specific rule. It's doable. And some routers, and one of the best examples is Cisco ISR. They're doing the job really great. They're doing exactly what you expect. So they use standardized field from IPFix protocol, which is called forwarding status. And when you start filtering, when you deploy Flowspec rule to filter out UDP traffic on your borders, in IPFix telemetry, it will have specific flag called forwarding status, which is set dropped. It's amazing. It's just literally the best and only sane implementation of this reporting. Let me tell you how Juniper reports this kind of traffic. Despite of having support for IPFix protocol, they use encoding, which assumes that if route, like, of course, first thing you need to enable this behavior, you need to set engineering command, which is almost impossible to Google, but if you manage to find it, you partially solved your issue. After setting this specific engineering command, you need to find out specific flows exported by IPFix protocol, which have output port set to 0. And at the same time, they have next hop set to 0, 0, 0, 0. And this one means it was dropped. So after this calculation, you will be for sure have information about that. OK, this traffic was filtered out, at least by something. But there is another problem, because despite of having a standardized field for forwarding status, which may be set to discarded or accepted, we have no option to distinguish reasons of discard. It may be actually static ACL, it may be decision of router itself, because in some cases it may decide to drop some traffic, or it may be flow spec rule. And again, in complicated and large networks, it's really important to have this field which actually says that this one was discarded because of flow spec, and this one because of static ACLs. And unfortunately, for now, this approach doesn't exist. I believe, in general, only one way how we can stop DDoS attacks is by sharing tools, by sharing our knowledge about attacks, because there is a large gap about understanding what is DDoS attack. Because unfortunately, for many companies, they think that their expertise, their insights about DDoS attacks, it's something like their commercial interest, and it's not usual to find out public information. So for this presentation, I used information provided by NBIP Neves, and they're really great about it because they keep completely transparent. They publish lots of transparency reports. They share kinds of attacks they experience. They share dynamic, and of course, it's very useful for us to understand what kind of attack we have to be more prepared for them, and ways how we can actually make our network safer, more reliable. And I would love to invite you for our community forums. They are directly related with FastNetMon, and you can find lots of like-minded people who are actually also interested in protecting their networks. And I will be happy to answer questions.
Thank you, Pavel. We have time for 2 or 3 more questions. Any questions in the audience? Doesn't seem to be the case. Is there something in venue? It's also silence. So, Pavel, thank you very much for the presentation.